Hello, this is NTI 34. We're looking at trapezoids in the flip book. So actually, let's go back to the quadrilateral family tree. Quadrilateral family tree. And at this point, you should have already listened to Tyler Tarver's video. What we were doing is special parallelograms. So we go back up. We're still doing quadrilaterals, but our quadrilaterals are no longer parallelograms. In a trapezoid, we have, instead of both pairs of opposite sides parallel, we have exactly one pair of opposite sides parallel. So for our trapezoid, we have a pair of parallel sides. Let me extend that. And then these sides are not parallel. Okay, so these guys are parallel. These are not parallel. If these were parallel, we'd be over here. We would be a parallelogram. So exactly one pair of opposite sides parallel. That makes us a trapezoid. And then he also talked about a special kind of trapezoid, an isosceles trapezoid. And hopefully you remember what an isosceles triangle is. Isosceles triangle is a triangle in which two sides are congruent. Now, in a trapezoid, these two sides can't be congruent. And we didn't really talk about it a lot. We kind of skipped the part about proving parallelograms. But if this side is parallel and congruent, that guarantees a parallelogram. So these guys cannot be congruent. So if we have a pair of congruent sides, it's got to be these non-congruent, or non-parallel sides. So a isosceles trapezoid, we're going to have our parallel sides, and then the non-parallel sides are congruent. Now, Tyler Perry talked about in any trapezoid, the parallel sides are your bases. In the isosceles trapezoid, just like with the isosceles triangle, your congruent sides are called your legs. In any quadrilateral, all four angles add to equal 360. That's always true. Now, he kind of messed up a little bit because in a... Let me get more contrasting colors here. In a isosceles trapezoid, your base angles are congruent. Now, Tyler talked about that. Base angles are congruent, and that's the same as with your isosceles triangle. Base angles are congruent. And he said that these add to equal 180 because they're consecutive angles. These are parallel. But he kind of made it a little bit confusing, I thought, and I even waffled on whether have you guys watch that video or not. And I'm actually going to upload another video that will be optional. So if you feel like you're struggling, I'm going to upload another video for you to watch. It'll be optional. But that guy does a really good job. It's just long. You can fast forward to what you need. He does a really good job explaining things, better than I'm doing today. Does a good job of explaining things. He works a lot of examples. He has a class there. They ask him some really good questions. I felt like they were very valid questions. Valid in that if I were teaching, they're questions that I think you guys would be asking me. So one thing that Tarver messed up on, even in this trapezoid, the non-isosceles trapezoid, these angles are going to add to equal 180. I thought he made that a little bit confusing in his presentation. Because these are parallel lines, this is a transversal, these are same side or consecutive interior angles. They are always going to be supplementary, okay? So he kind of stumbled over that. I apologize. Nobody's perfect. I'm not perfect, okay? We all make mistakes. I still think Tarver is one of the best that I've consistently seen out there. Okay, so we have our parallelogram branch. Okay, these are special parallelograms. We have our trapezoid branch. Tarver also talked about a kite. A kite has no parallel sides. So notice coming off of our quadrilateral, we are grouping things by the number of parallel sides. So a kite has consecutive sides that are congruent. So in a kite, this is going to be congruent to this, this congruent to this. Okay, and then we're going to have some lapping properties in our diagonals. Hopefully some of you guys have built a kite. We've kind of got some kite weather out there today. Your diagonals are going to be perpendicular. This angle is congruent to this angle. This diagonal here, the diagonal that goes from, like if this right here, this is an isosceles triangle, okay? This would be the vertex of the isosceles triangle. This is an isosceles triangle. This would be the vertex. These two, the vertices are not congruent. The vertices that connect the non-congruent sides, those are the ones that are congruent. A good way to think about it, we haven't talked a whole lot about lines of symmetry, but I know you guys do know about lines of symmetry. The diagonal that connects the vertices of the two isosceles triangles, okay, if you can, look at that as two isosceles triangles. That diagonal cuts the kite into two congruent triangles. Okay, if you can, see those fold onto each other. That'll help you a lot. We'll talk more about that actually next week. The kite is next week. This week we're focusing on the trapezoids. Okay, so now jump in your flip book. That completes our quadrilateral family. Jump to trapezoids. Okay. So, a trapezoid, hope I'm lined up there. Trapezoid has exactly one pair of parallel sides. Those guys are parallel. So remember, what do we know? That means that this angle plus this angle, these add to equal 180. Okay, consecutive interior angles or same side interior angles, they add to equal 180. Okay, this is not a isosceles, so this angle is going to be different. Using a tick mark to distinguish that. That's different than that. These guys add to equal 180. okay? These are different than these because we're not to isosceles yet, okay? All right. Mid-segment. I'm not going to call that the median. Slightly different. This is your base. This is your base. Okay, doesn't matter which is which. Base 1, base 2, doesn't matter. To get the length of this, mid-segment, she's calling a median there, a little bit different. You're going to add your bases, divide by 2. Multiplying by 1/2 is the same as dividing by 2, right? Add your bases, divide by 2. We'll talk more about that, okay? Then we have the beautiful isosceles trapezoid. Anybody into stonework? This is your keystone. Oh, keystones are so beautiful. We still have exactly one pair of parallel sides. Let me go back to that blue pen. Where is that? One pair of parallel sides. These guys are parallel. So again, these still add to equal 180. Okay? Your mid-segment, I'm sorry, I can't say median. Mid-segment is equal to, and I'm going to write this a little bit different. I like it as B sub 1 plus B sub 2 divided by 2. That way, takes away the fraction. You guys weird out with fractions. Don't be weirding out by fractions, okay? No big deal. The legs are congruent. This is a leg. This is a leg. You guys miss my bad handwriting, don't you? Leg, leg. Legs are congruent. Okay, very special thing happens in an isosceles trapezoid. Diagonals are congruent. Where's our diagonals? Right here. They are congruent, but they do not bisect each other. If they bisected each other, it would be a parallelogram, okay? No. Yeah, it would be a parallelogram, okay? Base angles. Base angles are congruent. Two pairs of base angles. That angle is congruent to that angle, because this is one base. And this angle is congruent to this angle, because this is a base. Okay. Also remember, because these guys are parallel, let me go back to this. This angle plus this angle equals 180. This angle plus this angle equals 180. Okay? It's because of the parallel. All right, everybody, all good there, I hope. Okay. Move this up some. We've got some examples. Okay. Parallel. These two angles, these are consecutive interior angles or same side interior angles. Parallel lines, transversal. Guys, this is technically an old problem, okay? This plus this equals 180, okay? Consecutive or same side interior angles add to equal 180. Combine like terms. 25x plus 5 equals 180. Subtract 5. So 25x equals 175. Divide by 25. X equals, let's see, 100 divided by 25, that's 4. And then I got 3 more 25s, so 7. Is that right? I hope it is. Okay. Example 2. AB is AB. Where's AB? Here's AB. 7y plus 6. EF is 5y minus 3. DC is y minus 2. Find y. Okay, this is my mid-segment. I add these, divide by 2, set it equal to this. So 5y minus 3 is equal to the sum of these. I'm going to combine like terms. 8y plus 4, 6 plus negative 2 plus 4 divided by 2. Okay, interesting option here. I could multiply both sides by 2, or these are both divisible by 2. So I'm going to just divide both of those by 2. I hope everybody is good with that. So this is 5y minus 3 equals 4y plus 2. Simply divided both of these by 2. Or you could think of it, I distributed 1/2. However you like that, okay? That's something you could use your photo math on. There you go. Solve for y. Subtract 4y from both sides. So you got y minus 3 equals 2. Add 3. Add 3. Y equals 5. Solve for y. I did. Okay. Hope everybody's good on that. Example 3. DONE is an isosceles. I'm going to put my little tick marks there just to remind myself. Isosceles trapezoid. Measure of angle EDO is 110. Measure of angle DEN is 15x minus 5. Find x. Well, it didn't have to be isosceles for that, did it? Because what do I know about this and this? These are consecutive or same side angles. They add to equal 180, right? So I don't care it's isosceles. What's up with that? Okay, these add to equal 180. Oh, hey, what could I do? If this angle is 110, what's 180 minus 110? That's 70. This angle has to be 70 degrees. So why don't I just do 15x minus 5 equals 70? Everybody cool with that? Okay, smaller numbers. I always like smaller numbers, don't you? Okay, so add 5. By the way, I got an app that supposedly I can flip this if I mess this video up. I'm trying, guys. I'm trying. I'm sorry. That's the main complaint I got. X equals 15. 2 15s is 30. 3 15s, 75. Is that right? 3? No. 6 is 60. What? Good Lord, my head went out the window. 2 15s is 30. 4 is 60. 5 is 75. Yes, there we go, 5. Good golly. Excuse your I am your geometry teacher, not your arithmetic teacher. So I need my Caleb's and who's on my arithmetic people. I am missing you guys so much because y'all, I wasn't playing when I said I couldn't do arithmetic. I'm not good. Trapezoid, T-R-A-P, is an isosceles one. Are they luring me into a trap? You miss my puns, don't you? Okay, do I really need to know it's isosceles this time? Isosceles trapezoid. If PR, where's PR? PR, oh, that's a diagonal. PR. And TA. They give me PR and TA. My diagonals. Up. Diagonals are congruent for an isosceles trapezoid. Did have to know this one was isosceles. So diagonals are congruent. These are my two diagonals. So I just set those equal, okay? So no, the trap was not a trap. I miss you guys so much. Out of all of you, there's always one or two that will just laugh at my stupid stuff. My husband doesn't laugh at my stupid stuff. Okay, so I get 3x equals 27. Divide by 3. Hey, this one I know. 3 times 9 is 27. X is 9. Find x. Boom! We're good. We're done. This is your NTI 24. Hang in there, guys. You don't get to come back and see me. It breaks my heart. I miss y'all. So on this, you don't have to send me a picture of it. Just do it. Mark it as complete. Make sure that you've got it. You will need to use it to do your practice problems. Tomorrow, we will do some practice problems, and then you'll have some problems to practice on your own. But I hope you are doing well. The only good news is we will be wrapping up a little bit early. So more to come on that. Take care, guys. Love and miss you all. Could send me a picture of your smiling faces because I do miss those oh so much. Take care, guys. Peace out.